All right, greetings, scholars. We're closing out chapter 2 with section 2.7 on linear inequalities and absolute value inequalities. A few learning objectives. In this section, you will use interval notation, use properties of inequalities, solve inequalities in one variable algebraically, and solve absolute value. Hang on. Why does it look like that? And solve absolute value inequalities. So using interval notation, indicating the solution to an inequality such as x is greater than or equal to 4 can be achieved in several ways. We can use a number line as shown in figure 2. The blue ray begins at x equals 4, indicated by the arrowhead, continues to infinity, which illustrates that the solution set includes all real numbers greater than or equal to 4. We can also use set builder notation. This is going to be like the set of all x such that x is greater than or equal to 4. And then we can use interval notation as shown here. Okay. So the set indicated set builder notation and interval notation, all real numbers between a and b but not including a or b. So we can show it this way, and in interval notation it looks like this, right? So we'll come across many of these as we go through examples. I'll just, you can always pause this screen to look at it further, but I'm just going to move forward. So use interval notation to indicate all real numbers greater than or equal to -2, right? So usually what I like to do, I like to start with my number line. And we want numbers greater than or equal to -2. So all I really need on a number line is -2. And if we want all real numbers greater than or equal to 2, so that means our numbers need to go in this direction. And because it can be equal to 2, I'm going to use a square bracket. You might also see it as a closed circle. So a square bracket and a closed circle mean the same thing, but I use a square bracket because it just makes it easier to translate to interval notation. The square bracket means we include that number, right? Not only do we get really close to that number, but we also include that number. Versus parentheses or an open circle, we get really close to that number, but we don't include that number, right? If it were parentheses. Okay, so if we want this in interval notation, we're talking about all the numbers from -2 to the right. So we're going to positive infinity. Infinity always gets the grouping symbol parentheses. And in this context, because we include -2, we use a square bracket. Okay. So it should be 2 to infinity. Sorry, -2, right? Yeah, -2 to infinity. Write the interval expressing all real numbers less than or equal to -1 or greater than or equal to 1. Let me see. Okay. All real numbers less than or equal to -1. So here, let's start with our number line. So if we want numbers that are less than or equal to -1, so here's our -1, or greater than or equal to 1, and here's 1. I'll put these in chronological order or ascending order. So if we want the numbers less than or equal to -1, so we want all numbers going in this direction. Okay. And let me see, less than or equal to -1, so that means we use a square bracket. Or greater than or equal to 1, so we want all the numbers to the right of 1. And then it says it can be equal to 1, so again we use a square bracket. Okay. So then if this is the graph for this statement, then for me it's easiest to translate from the graph to interval notation. So the far left is what? Negative infinity. I keep forgetting to change my color. The far left is negative infinity up to -1. And then we want the numbers from 1 to infinity. Infinity always gets parentheses. -1, because we include it, we use a square bracket, same thing for 1. And we put these two, we combine these two sets with the symbol called union, right? So our solution set can come from the left half or the right half. Did they change my thing again? All right, let's just go. Okay, so we got this result. Okay. So properties of inequalities, we have the addition property. If A is less than B, let me see these properties. Okay. Then we can add the same real number on either side of the inequality to preserve the inequality. If A is less than B and C is positive, we can multiply both sides of the inequality and preserve the inequality. And if A is less than B and C is negative, when we multiply both sides by C, the inequality flips. All right. Okay. Let me see. So illustrate the addition property for inequalities by solving each of the following. So then for A, we have x minus 15 is strictly less than 4. So we can just solve this like an equation, right? If this were an equation and we were solving for x, we would add 15 to both sides of the inequality. A number plus its opposite, these add to 0. So then we say x is less than, what is that, 19? And then a quick graph for that. Say this is our 19. If the alligator is eating a bigger thing, so that means our numbers are smaller, so our numbers go to the left. And because it's not equal, it can't be equal to 19, we're going to use a parentheses, which means we get really close to 19, but we don't actually reach it. We get really close to 19, but we don't reach it. So then in interval notation, the far left is going to be negative infinity up to 19. Infinity always gets a parentheses, and in this context, because we don't include the number 19, we use a parentheses. Okay. So then, and we can check this, right? So we're saying basically any number less than 19 should make the original inequality true. For instance, let x be, let's just do 0, right? If x were 0, it's true that negative 15 is less than 4. Let's do 18. 18 minus 15 is 3. Notice that 3 is less than 4. We can even do 18.99999, right? Anything less than 19 is going to work. Now, if we try 19, 4 is not less than 4, right? So notice that. Okay. So then B. We got 6 is greater than or equal to x minus 1. Okay. So again, if this were an equation, we would add 1 to both sides. We get 7 is greater than or equal to x. Right? So let's graph this real quick. Okay. So then here's our 7. If the 7 is big, the alligator eats the bigger thing. So if that means 7 is bigger than our numbers, so then our numbers need to go off to the left. Okay. And because x can be equal to 17, we need to use a square bracket. Okay. So then here, the far left is negative infinity, to write it in interval notation. The far right is 7. Infinity always gets a parentheses, and because we include the 7, we use a square bracket. And then for C, we have x plus 7 is strictly greater than 9. Subtract 7 on both sides. What is that? 2? Again, I just feel like the easiest way to see this is just do a quick graph. So if the alligator eats the bigger thing, that means our numbers are bigger than 2. So our numbers go off to the right. Okay. And we use a parentheses because we don't include the 2. That means we use you can use a parentheses or an open circle, but then when we write it in interval notation, we need to use either parentheses or brackets. So then now to translate this, we're going from 2 to positive infinity. Infinity always gets a parentheses, and then 2 in this case gets a parentheses. Okay. Okay, and they didn't write it in interval notation, but that's okay. X is less than 19. 7 is greater than x is greater than 2. Okay. Illustrate the multiplication property for inequalities by solving each. Okay. So then for A, we have 3x is less than 6. Again, we just kind of treat it like an equation. So if we have 3 times x and we want to isolate the x, we use the inverse operation of multiplication, which is going to be division. So we divide both sides by 3. Okay. So then that gives us x is strictly less than 2. I guess we could stop there because that's where they stopped on the previous. Okay. B. Negative 2x minus 1 is greater than or equal to 5. Okay, so we just treat it like an equation. First, we can add 1 to both sides. So then it's going to give us a negative 2x is greater than or equal to 6. Now here, we're dividing both sides by a negative 2. Okay. So then when we do this, because we're multiplying or dividing by a negative, the inequality flips. Okay. And that leaves us with negative 3. Again, if we wanted to check something like this, we're saying any number less than or equal to negative 3 should work, all right? So we can use numbers like negative 4, negative 5, negative 6. We can actually use negative 3 itself, all right? But if we chose negative 2, it should not work. If we chose 0, it should not work, right? Because if we plug in 0, we get negative 1. Negative 1 is not greater than or equal to 5, right? But if we chose something like, let's do negative 10. It's kind of big. Let's do negative 4. So then negative 4 times 2, negative 2 is what? 8 minus 1 is 7. Notice that 7 is greater than or equal to 5. Okay. So then C, we have 5 minus x is strictly greater than 10. Okay. I'm going to subtract 5 on both sides, and I'll get this result. And then we can multiply both sides by a negative 1, but again, if we multiply or divide by a negative, the inequality flips. So x is strictly less than negative 5. Just trying some gestures, sorry. X is less than negative 2, less than or equal to negative 3, strictly less than negative 5. Okay. Okay. So again, we're just going to treat this like an equation. We're working with, we have 13 minus 7x is greater than or equal to 10x minus 4. Okay. To try to minimize multiplying or divided by a negative, I'm going to go ahead and add 7x to both sides. That's going to give me 17x. And I'm going to add 4 to both sides. That's going to give me 17. So now I can divide both sides by 17. We get 1 is greater than or equal to x. Easy. That was easy peasy. I don't know what's going on with my voice. 1 is greater than or equal to x. All right. Okay. All right. And let's go ahead and put this in interval notation. Okay. So here's our 1. If the alligator eats the bigger thing, that means our numbers are smaller. So our numbers go to the left of 1. Okay. And because it can be equal to 1, we use a square bracket. Okay. So then from here, I feel like it's easiest it's easiest to go to interval notation. The far left is negative infinity up to 1. Infinity always gets a parentheses. 1 gets a square bracket. Okay, this one asks us to solve the following inequality and write the answer in interval notation. So let me see, we're working with, we have this negative 3 by 4x is greater than or equal to a negative 5 by 8 plus 2 by 3x, okay? So I'm a fan of, whenever I have fractions, I'm a fan of clearing out the fractions. And we can do this by multiplying the left and the right by the least common multiple, right? So one way to find the least common multiple of the denominators. So with something like this, one way to go about this is take your largest denominator, which is 8, and then just start testing multiples, right? So is 8 a multiple of 4? Yeah. 8 is a multiple itself, but 8 is not a multiple of 3. So then now we multiply by 2 to give us 16. 16 is a multiple of 4. 16 is a multiple of 8, but it's not for 3, right? So then we're going to say 8 times 3 is 24. 24 is a multiple of 4. 24 is a multiple of 8. And 24 is a multiple of 3. So what we're going to do is multiply the left and the right by 24 to clear out our fractions. Okay. So we're going to say this guy times 24. And this guy times 24. And we're going to need to distribute the 24. Okay. Now on the left, 24 divided by 4 is 6 times 3. That's going to be a negative 18x. Okay. For the first term, 24 divided by 8 is 3 times 5 is going to be 15. 24 divided by 3 is 8 times 2 is 16x. Okay. So we at least cleared out our fractions. I'm going to add 18x to both sides and add 15 to both sides. So if I add 15, it'll be here. If I add 18, 14, so I think that's 28, it must be 34. Wait a minute. 26. Yeah, 34. And then I can divide both sides by 34. Let's see. That's what, 2 and 17? Okay, so it looks like we leave it as 15 over 34. Let me make sure I didn't make any mistakes. Or I mean, we can check it by choosing a few test points. 15 over 34 is just below a half, right? So we could choose numbers like 0 or any negative number, or like, you know, basically any number less than 15 over 34. Let's try when x is 0. On the left we get 0. is bigger than a negative number, right? So that one checks out. But if we use a number like 1, it should make it false. Yeah, I don't feel like dealing with those fractions. So what else could I use? 24. Yeah. But I mean, we could use a calculator. I'm just being a little bit lazy. Okay. Oh, and then write the answer in interval notation. Okay. So then for this, let's graph it. Again, I'm just a fan of graphing these. Here's our 15 over 34. And if that number is bigger than ours, then our numbers go off to the left. Right? And because it has a bar, because it can be equal to this number, we're going to use a square bracket. Okay? So then now we can see the far left is negative infinity up to 15 over 34. Infinity always gets a parentheses. And because we can be equal to this number, it gets a square bracket. Okay. So it looks like with theirs, they kind of work with the fractions. I mean, and that's okay. There's nothing wrong with that. But notice we got the same result. I'm just a fan of clearing out fractions and then, whenever I can. Okay. So this is a compound inequality. We have 3 is less than or equal to 2x plus 2, which is less than 6. Basically, whatever we do to one part, we do to all 3 parts, right? And we're still trying to isolate the x. So first thing I'm going to do is subtract 2 from all the parts, all 3 parts. Okay. Now, on that left part, we get a 1. This just comes down. Now here we have a 2x. This comes down, and that's a 4. So now we can divide all parts by 2. Here we have a half. It's less than or equal to x, which is less than 2. Let me see, how do they want their answer? Okay. So then, if we're going to write this in interval notation, let's start with the graph. Here's our 1/2. Here's our 2. Okay. X is bigger than 1/2, but less than 2. So we're pretty much talking about all the numbers from 1/2 to 2. Okay. Because the 1/2 has an equal to, has that bar, we use a square bracket. But because the 2 does not have the bar, we use a parentheses. So then, now we're ready for interval notation. So we're talking about all the numbers from 1/2 to 2. Again, the 1/2 gets a square bracket, and the 2 gets a parentheses. Okay. Solve the compound inequality with variables in all 3 parts. Let me think about it. Okay. So for something like this, I would break it apart. Let me think just for a moment. Yeah, I think we can break this apart, right? So we're starting with 3 plus x. Let me clean that up a bit. 3 plus x is strictly greater than 7x minus 2, which is strictly greater than 5x minus 10. Now this is the same as, we can break it apart in the following way. If we take the first two, we have 3 plus x is strictly greater than 7x minus 2, and, okay, we have what? 7x minus 2 is strictly greater than 5x minus 10. Then we solve each one separately, right? So from the two on the left, if we subtract x, we'll get a 6x here. Add 2 on both sides, we get a 5. Divide both sides by 6. 5 over 6 is greater than x, okay? And here, I'm going to subtract my 5x. It'll give me a 2x. I'm going to add 2. That gives me a negative 8. And then divide both sides by 2. Negative 4, okay? So then if we put this in order, it looks like we're finishing with the far left is negative 4 is less than x. Let me think, is there another way I could have done this? I'm sure there is, but this is fine. And then that's less than 5 over 6. Okay. And then we can put this in interval notation. And we can check it as well. So say here's our negative 4. Here's our 5 over 6. Okay. So we want pretty much the numbers between these guys. But we don't include those endpoints, so they get parentheses. Right. So then we're talking about the numbers from negative 4 to 5 over 6 in parentheses. Okay, so we're saying that these are the numbers that should work, right? So for instance, a number that should work would be something like 0. If we plug in 0 into the original, 3 is bigger than negative 2, which is bigger than negative 10, right? That one checks out. But if we try a number like 1, that should make it false. So then 4 is not bigger than 5, right? Because if we plug 1 into the middle one, we get 5, so that makes it false. If we try negative 15, it should make it, negative 5 should make it false. Negative 15 will make it false as well, but if we try negative 5, right? Negative 2 is bigger than negative 37, but negative 37 should not be bigger than 35. Right? It's not. It's smaller. All right. So it fails the second one. Right. So we can be confident in this one. All right. So let's try the first method. Write 2 inequalities. That's fine. Okay. Let's see the second one. Oh. Okay. Yeah, that's fine. Yeah. So they did exactly what we did. Let me see. Absolute value inequalities for an algebraic expression x and k positive. An absolute value inequality is an inequality of this form. We have the absolute value of some expression less than a positive. When you have an absolute value less than a positive, we can rewrite it basically in this form. Negative k is strictly less than the expression, which is less than the positive, right? If you have an absolute value is larger than a positive, then you have to break it apart. The expression is, I just rewrite it like the expression is greater than k, or the expression is, and then you flip and flip. So the expression is less than negative k. All right, okay, this is fine. Describe all values with a distance of 4 from the number 5. So a distance of, describe all values of x within a distance of 4. So the smallest the number can be will be a 1. It's basically all the numbers from 1 to 9. And we can use square brackets. Right? Because if we're at 5 and we subtract 4, we're at 1. If we're at 5 and we add 4, we're at 9. And we're talking about all the numbers between and including those endpoints. Okay. Oh, absolute value. I forgot about that. Okay, I'm just going to let that be. Let's try a different one. Okay, let's do this one. So we have the absolute value is less than 3. This absolute value expression is less than 3. Let me think. Okay. So when it's less than, for something like this, you just rewrite it without the absolute value. So we're going to say x minus 1 is less than or equal to 3. And then we tack on, I'll do it in purple, we add this other part. Right? We can do it like this. Okay. So then we just solve this guy for add 1 to all 3 parts. Plus 1, and plus 1. On the left, we get negative 2. We get our x. And we get 4. So we're talking about all the numbers from negative 2 to 4, including the endpoints. So if we choose a number like 0, it should work. Absolute value of negative 1 is 1, which is less than or equal to 3, so that checks out. But if we choose a number like 5, it should fail. 5 minus 1 is 4. Absolute value of 4 is 4, which is not less than 3, right? Okay. So let me see. Given this equation, determine the values of x for which the values of y are negative. So we want this to be what? Less. We want y to be less than 0. Okay. So if we want y to be negative, well, we have an expression for y, so let's go ahead and use that expression. We got this negative 1/2 times the absolute value 4x minus 5, absolute value plus 3. Now, before we apply those properties we saw a few slides back, let's go ahead and isolate the absolute value. First, I'm going to subtract 3 on both sides. And I'm going to be left with this. Everything else just kind of persists. Okay. So then, if I'm still isolating the absolute value, let's move that negative 1/2 to the other side. So we can multiply both sides by negative 2. Okay. So we're going to say this times negative 2 and this times negative 2, right? So I think these guys are going to cancel. On the left, it looks like we are left with our absolute value, our desired. But notice we multiplied or divided by a negative, so the inequality flips. And on the right, we get 6. Okay. So now, so let me see, who's it? So now we have an absolute value that's greater than 6. So for that one, the way, when it's greater than, like when the absolute value is greater than a positive, first I just rewrite it without the absolute value. We're going to say 4x minus 5 is greater than 6. Then we say or 4x minus 5, and then we flip and flip. So it's going to be less than negative 6. Okay. As opposed to what we had in the previous, we had the absolute value was less than. When the absolute value is less than, we just tack on that purple part that we see there. When the absolute value is greater than, then we have to do this or flip thing. Okay, so then we solve each inequality separately. We add 5 to both sides. So then we get 4x is greater than 11. Divide both sides by 4. This is going to be 11 over 4. Or, again, add 5 to both sides. So that's going to be a negative 1. Divide both sides by 4. Okay. So then if we were on a number line, here's our negative 1 by 4. I'm putting this in sequential order. Here's our 11 over 4. If x is bigger, oh, let's see, this is interesting. Yeah, okay, I think we're okay. X is strictly larger than 11 over 4, so we're talking about the numbers in this direction. And because we're not equal to, there's no bar, that means we use a parentheses. I don't know why I can't draw parentheses today. That's fine. And then if x is less than -4, for that part, we're talking about the numbers in this direction. Let's try that again. And again, there's no bar, so we use a parentheses. So now that we have the graph, I feel like from there it's easiest to write the interval notation. The far left is -infinity up to -1,4. And then we got 11/4 up to +infinity. Infinity always gets a parentheses. And because we don't use either of these endpoints, they also get parentheses. And then we combine these two sets with the union. In the holiest of matrimony. Every time I hear the word union, I think of a wedding. Marriage. Okay. Let's see. And again, we can check, right? Like a number, we would check numbers that should make it true and numbers that would make it false. For instance, a number that would make it false is like when x is 0. If we try 0 into the original, we get a result of a -5/2 plus 6/2 is a 1/2. All right, which is a positive number, right? But we want it to be negative. So, which confirms what we anticipated. That's a 12. So for instance, 3 should make it true. If we plug 3 into the original, 12 minus 5 is what? 7. -7/2. So then we're going to get a -1/2, all right? If we did 12, I think. So we get a negative result, which was what we wanted, all right? So again, we could just choose several test points, plug them into the original. You can even do this in your calculator. You know. If see, I get way too many. Let me turn my focus on. I'm getting too many. Let's do this one. Okay. So now we can examine the graph to observe where the y values are negative. We observe where the branches are below the x-axis. Notice that it's not important exactly what the graph looks like as long as we know that it crosses the horizontal axis at -1/4 and the graph opens downward. I feel like something's missing. I mean, but I think they got the same result that we got, so they didn't write the interval notation. Okay. All right. So with that, we're going to go ahead and end the session here. And from one beautiful mind to another, have a wonderful day. Take care. Peace.